Hi, this is Rob Yates, and this is the video for Classwork 4 of Unit 6. Make sure you put your first and last name up here, and what period you have math. Alright, Deshauna and her team gathered data for their ball drop and recorded it in the table shown below. They want to know what's the rebound ratio. So to figure that out, we have to divide the rebound height from the drop height. For instance, for the first one here, it would be 124 divided by 150. If you plug that in, you get 0.827. Now we're going to do 59 divided by 70. And we're going to get 8.47. 100 divided by 120 is 0.833. 83 divided by 100 is 0.83. If you divide 92 by 110, you get 0.836. And finally, 33 divided by 40, you get 0.825. You can see these are all very similar. I want to add them all together and divide them by 6, the number of times there are. If you add them all together, what you get is 4.998. And if you take 4.998 and you divide it by 6, what you get is a rebound ratio of 0.833. I'm going to use that as a tool. We're going to say from whatever height you dropped your ball from times 0.833, that's going to equal the rebound height. Alright, says now predict how high, Deshauna's ball will rebound if it's dropped from 275 centimeters. So this is round your calculations to the nearest reasonable decimal place. So we're going to take 275, and we are going to multiply times 0.833. What do you get? I'm going to let you figure that out. I'm sure you've got a calculator and you can do it. Then it says suppose that the ball is dropped and you see that its rebound height is 60 centimeters. From what height was the ball dropped? So they want us to work backwards now. They're saying this ball bounced 60 centimeters. How high was it when it dropped? So what we know is that 0.833 times however high it was when it dropped, we'll call it x, equaled 60. So to find out what x is, we just divide by 0.833. 60 divided by 0.833 equals what? It's going to be more than 60. And it's going to be in centimeters. Just like this is going to be. It says suppose the ball is dropped from the window 200 meters up on the Empire State Building. What would you predict the rebound height to be? Well, meters and centimeters, the rebound ratio is going to be the same. So we're going to go 200 times 0.833. What do you get? That is going to be in meters. What about the second bounce? Well, you have to take your number from the first bounce, which I'm going to tell you, since it's an important part of this equation, which is 166.6, if you didn't get it already, and you multiply that by 0.833. 166.6 times .833. What does that equal? That's also meters. It says that a tennis ball must rebound approximately 111 centimeters when it's dropped from 200 centimeters. Suppose you drop a tennis ball from a height of initial height of 10 feet. What would the first rebound be? Okay, first of all, we have to figure out what our rebound ratio is, right? So, we're going to take 111. It's supposed to be 111. And we're going to divide it by 200. What do you get? That's right. If you got 0.555, you have the ratio now. So how high would it rebound from 10 feet? So that would be 10 times 0.555. It equals a number. You take that number, you multiply it times 0.555, and you get the second number. Then it says, how high would it rebound after the fifth bounce? Now, you could take what you came up for the second bounce, multiply it times 0.555 for the third, and then times 0.555 for the fourth, and then times 0.555 for the fifth, or you could do this. 10 times 0.555 to the fifth power. There's your answer. Write it down. Lona received a stamp collection from her grandmother. Isn't that nice? The collection is in a leather book, currently has 120 stamps, and Lona joined a stamp club which sends her 12 new stamps each month. The stamp book holds a maximum of 500 stamps. Complete the table at right. All right, well, we know that it is plus 12 each time, right? 120 plus 12 is 132. Plus 12 is 144. Plus 12 is 156. Plus 12, I think you get the idea. Plus 12, go ahead and fill out the table. Then it says, how many stamps will Lona have a year from now? Well, we can either use plus 12 for 7 more times, or we can realize that we've got a linear relationship here. In other words, it's adding 12 each time. That's the change. And it starts with 120. So M equals 12, and B equals 120. And if you plug in Y equals 12 times 12 plus 120, well, what do you get? If you said 264, you were right. It says write an equation using function notation to represent the total number of stamps that Lona has in her collection after n months. Let the total be represented by Tn. So if you remember this function notation, our Tn takes the place of Y. Oh my goodness, I'm messing this up, aren't I? Here, we'll just start over. T n equals 12n plus 120. There is our functional notation. This is gobbledygook. D says solve your equation from part C for n when Tn equals 500. And it asks, will Lona be able to fill her book exactly with no stamps left over or remaining? How do you know? When will the book be filled? All right, well, we're just going to plug 500 in for Tn and see what happens. 500 equals 12n plus 120. And we're just going to go about solving for n just like you would solve for x. So the first thing we need to do is subtract 120. And what you get is 380, and I'm just going to go ahead and write it next door here because I'm running out of space, equals 12n. And then I divide by 12. Sorry, that's supposed to be 380, not 38. And when I divide 380 by 12, what I get is n equals 31.66, and it goes on for a while. So the answer to the question is, will she fill her book exactly, is no. She's going to have some stamps left over from that 32nd month. Looks like she's going to have roughly 4 stamps left over. If you figure that 0.66 is 2/3, and 2/3 of 12 would be 8. So you'd have 4 stamps left over. So the book will be filled in 32 months with leftover stamps. Alright, that concludes our homework video for today. Please remember to consult your algebra teacher for any other questions you might have. And remember, there are tutors in the library before and after school, several of whom are bilingual. So, see you next time.